So I'm going to discuss a couple problems. One is, there was a problem about the number 9. Okay, there was this question about Stephen write the list of consecutive integers starting from 1 at the speed of 5 digits per second. What will be the sum of the final 2 digits he writes on his list at the end of the 10 seconds? Okay. All right, so let me write down the problem. Okay, you already have one there. Is you going to write the list of consecutive integers? Okay, 1, 2, 3, 4, 5, and keep it going. Okay, and the speed is at the speed of 5 digits per second. Okay. Now for the problem context, of course, they're going to ask you to find the sum of the last 2 digits to write down. But here, I wanted to find out what is the last digit he writes on his list. Okay. At the end of 10 seconds or maybe 20 seconds. So this is a question. Okay. So think about per second, right? Per second, 5 digits. So that means 10 seconds, you write down 50 digits, right? So in 10, yeah. So that's okay, 50 digits, okay, at the end of 10 seconds. So 50 digits, right? And when you write down numbers, like from 1 to 9, how many digits, right? From 10 to some number, you're trying to, if you write down the whole number, you will get, suppose n, you write down the last integer, okay? Then how many digits you're gonna get? Total, you have 9 digits, the number of the digits, right? The number of digits, how do you count? But for 2 digits in each integer, you have every time you write 2 digits. But this is going to be n minus 9, this many 2 digits integers. You have to multiply by 2, okay? So the sum is, suppose you write down the integers, right? Complete the integer. Then this is the number of digits you're going to use. So the sum will be 9 plus 2n minus 9 is going to be 2n minus 9, okay? So 9 plus negative 13. 9 plus 2n minus 18, so it's going to be minus 9, okay? So this is supposed to be 59 digits. Let's try to 59 digits, okay? So then you will get, okay, 50 digits, not 59 digits. 50 digits, right? So you're going to use 50 digits. So you get 2n minus 9, you get 59. Of course, it's not divisible, okay? You cannot divide by, okay? So n is a 59 divided by 2, so it's 29.5. So what does that mean? That means you cannot finish the last 2 digits integer. Okay? So what they did is, yeah, you write down, you know, here's 1, 2, 3, all the way to 28, then 29, then at the moment when you write 30, you stop that. you stop there. So you stop here, 29.5, okay? You cannot complete the last two-digit integer. You only write down one integer. If you write down two, so total number of digits you wrote down is going to be 60 digits instead of, 51, yeah, 51. So plus 9 is going to be 60 divided by 2 years. So you stop there, okay? So this is the 50th digit, okay? And then you put 0 there, then you get 51st digit. Okay? So what is the question? What is the last digit he write down on his list? That is a 3, okay? That is going to be 3. Then you see that if you count them, so you get 49 digits here. 49 plus 1 is 50. Okay, 49 digits used. Okay. So that, of course, the problem on the contest, it says that 9 plus 3 is 12. Okay, 9 plus. So I just ask you to find the sum of the final two digits he writes. Okay, but if you figure out the last digit he writes is 3, then you know it's a 9 and the 3, the last two digits. Okay, so this is a problem, right? Emma, you have some troubles, right, to do this. All right, so the next problem is going to be, it's called a gumball machine, contains 12 red gumballs, 6 blue, and let's put here 12. So one red marble, doesn't matter. So we have 12. Total is 12, right? And one white, and 7. Okay, sorry, 6 blue. I missed that. Yeah, blue, and the 1 white, and the 7 green. Okay. So what is the least number of gumballs child must buy to guarantee having 3 gumballs of the same color? Let me write down the question. Yeah, this is an important problem. Sometimes when you go outside, you're trying to get 3 identical color, gumballs, right? And you want to, how many you have to buy? Sometimes you're lucky, you don't need to buy so many, but at least you prepare the worst. You have to spend so much money to guarantee 3 of the same color. Okay, so how do you do that? That's the trick is you select the worst case. Okay, so you try to make them all different as different possible. So you buy the 1 red, then 1 blue, right? Then 1 white, 1 green. Okay, then you already buy 4. Then you try to make it different, right? So that's worst case. Then you buy a red, right? And you buy 1 blue, okay? Then since there's no white left, so you buy green, okay? Okay, so that's the worst case. So how many already? Then 1, 2, 3, 4, 7, okay? Then the next one, whatever you're gonna buy, cannot be white anyway. There's white already gone. So you can buy red one, buy blue one, buy green one. Doesn't matter, okay? So you can always have 3 balls of the same color. So total you need, that's just worst case, 8, okay? So if you buy 8, and I guarantee you will get at least 3 of them have the same color, 8. The answer is 8. Okay, no matter how, yeah. So that's the answer, okay? So what they do is you just, you see them, right? You suppose you can see all of them. You do make the worst case, right? The worst case is by each time by balls in different color, because you have only have 4 different colors. So you still have the second round have to be repeated by 1, 2, 3, 4. Then the next one you have to buy all the 3 different colors: red, blue, green. Then the X one, whatever you're gonna buy, you're gonna get 3 balls of the same color. Got it? Yeah. So you just assume that you see all the balls there, okay, in all the colors. Then you just pick. Then you can. Then you try to select the balls of different color. Those are the about the counting problems. If you do have problems which not discussed in today's lecture or yesterday's lecture, then you can contact me. Okay, send me the list of the problems. All right. So now our next problem is, we have 3 circles here. Remember this problem, right? Some students got 3 circles, coplanar circles, intersect as shown. What is the maximum number of points on the circles that a line passing through all 3 circles can touch? Okay, so I think you just need to, for this problem, the same, it's maximum minimum value problem, right? Similar to the above. So what is the maximum? You just try use a all right. So you have to draw the line to find the intersection point, number of the intersection point. So just randomly try this, right? Then you see you get how many intersection points? 1, 2, 3, 4, 5, 6. Okay. Now, why you cannot get more than 6? Here's the proof. Maybe you're just in bad luck. You cannot get more than 7. Why? Okay, you cannot have a, here's a, get number of students get a 6, okay, 6 intersection point. And then try many different ways, you cannot get no more than a 6. Why you cannot get 7? How do you prove that? Okay, it's easy to see, you get 6 intersection point. Okay, the reason is, if you have a circle, right? If you have a single circle, a line passing through this circle, you can only have 2.
You can't get 3 points on one line.
That's right. Okay. So you have to draw a line passing through 3 circles. You just look at each circle. Look at the first circle, you find only 2 points, right? And then you look at, that one. Let's use the A and A. Then you look at another circle, B and the B. Then look at third circle, C and the C. So that's a proof. You can, for no more than 2 intersection point for one circle with a line. So that's why total you cannot have more than 6. Okay, so the answer is the maximum number is 6. Okay. And you can also, you can find such line with 6 intersection points. right? So you not only get answers, you have to also feel confident you get the right answer, okay? You have to find proof there are no more than 6 intersection points, okay? So, all right, so I'm going to begin with my main topic here today. So the first topic I want to talk about is about the operation, okay? So operations. In mathematics, what does operation mean? Well, we can define something. You know, we already learned, right? Plus, minus, division, multiplication. Those are called operations. So 3 plus 2 equals 5. Okay, 3 plus 4, 2 equals 5. And then 6 divided by 2 equals 3. For example, right? We human being defines 4 operations. Okay? But you can also use those 4 operations to define new operations. For example, we can define x as plus circle y. Okay? It's going to be plus x plus y, or x or y, y, x plus y, then minus x times y. Okay? And this is also we define this new operations. So then you can calculate 1 plus 3. Okay? Circle 1 plus circle 3 is going to be 1 plus 3 minus 1 times 3. So the answer is 1. But if you interchange 3 plus 1, you also get 3 plus 1 minus 3 times 1. It's 1. So in general, okay, we always have for this, you can commutative, okay? So it's always true in general, okay? It's true in general, holds true, right? Yeah, let's look at this. 1 plus 2 and plus 3. And the minus 1 plus 2 plus 3. How about this? Do they equal? Okay, and then we just do the calculation, okay? So this side, 1 plus 2, 1 plus 2 is going to be 1 plus 2 minus 1 times 2, which is 1. Okay? So 1 plus 2 plus 3 is going to be 1 plus 3, which is 1 plus 3 minus 1 times 3, which is also 1. Okay? All right, now let's do the next one. Okay, 2 plus 3. With 2 plus 3 minus 2 times 3, which is going to be 5 minus 6, negative 1. Okay, negative 1. Okay, then 1 plus 2 plus 3 is going to be 1 plus negative 1, which is going to be 1 plus negative 1 minus 1 times negative 1. So now this time, you are going to get 1 minus 1, and the minus, it's positive 1. Right? So these two is still equal. Right? Those two still equal. Okay. So, but the question is this true in general? It's true in general? You can check that. Yes, maybe not. Okay, let's compute. Okay, so A plus B and plus C is A plus B. So it's going to be A plus B minus AB. Then, according to the definition, plus C minus A plus B minus AB times C. Yes.
Don't you just take out the parentheses because you don't need them?
No, you cannot find it unless you prove doesn't where you put it. Okay. You cannot just remove the parentheses and have 3. You know, we only define a pair. But a pair of numbers, you can add them together. So according to the definition, so this is going to be A plus B minus AB plus C minus AC minus BC plus ABC. So actually it's going to be A plus B plus C minus AB minus AC minus BC and plus ABC. So I'm pretty sure this is going, those two are equal. Okay. So let's check. B plus C. Okay, B plus C is going to be B plus C minus BC. So A, okay, it's going to be A, okay. So let's work out, okay? So this is going to be A plus B plus C minus BC. And minus A, B plus C minus BC. And you are surprised that we get same formula at the end. Okay, so this is the same. But not always that, okay? Just for this special one. All right, I'm going to look at the next problem from book, okay? If the operation capital Z is defined as B plus 10A minus A squared. Yeah. What are the values of 2ZB, 2Z6, and 6Z2? Are they equal them? They just zip them together, okay? All right, so 2Z6 is going to be 6 plus 10 times 2 minus 2 squared, right? When A is 2. So it is going to be 20 and 2, so that's 22. Right? And the 6Z2 is going to be B is 2. A is 6 minus 6 squared. Okay? And let's calculate that. It's 2 plus 60 minus 36, 1. Okay? So 60 minus 36 is going to be 24. 24 plus 2 is 26. So clearly those two numbers are not equal, right? So that means 2Z6 is not equal to 6Z2. Right. Oops. Okay. So let's look at the next problem. Okay, I'm going to ask you to do that, okay? We define A loves B equals, okay, A over B plus B over A. Okay. All right, so find the 2 left 3. Okay, can you do that? All right, so according to the dimension, it's going to be 2 over 3, 3 over 2. Okay, and you combine them, it's going to 6, 4 plus 9, 13 over 6. Okay, so those are called the functions. And now my next topic is, let's begin with the following problem. If a squared equals 3 and a to the 4th power equals 5b squared, okay? Something like that, okay? Where a and b are positive number. Okay? Find the value a squared b cubed. Oh, this is a 5b cubed, okay? So when you solve this problem, when you're trying to solve this problem, you have options. You can find the A, then you can find the B, right? But that's not what we're going to do, okay? From the first equation, A is going to be square root of 3. Then from second equation, B cubed equals A to the 4th power divided by 5. And then blah, 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 you know. Then you can square root of 3 to the 4th power. And that's going to be square and the square, 3 square. It's 9 over 5. Then B is going to be the 3rd root of 9 over 5. Then you put them together, then you can get a square, right? A square plus b cubed, you know, it's going to be square of 3 times. Okay, and that just too much work. Okay, too complicated. Not the best idea. Okay. What I want to show you to do is you can bypass finding the value of A and B. Okay, so you go back to here. You go back to the problem. A squared equals 3, right? And then what we get here is A to the 4th power equals 5b cubed. So I'm going to find A squared, b cubed. Okay. So what you do is you can find, okay, here's A cube, here's A cube. So just replace B cube, yeah, B cube, replace B cube by A to the 4th power divided by 5, right? You don't need to find the B, just find the B cube. So you get 5, 8 to the power 6. But 8 to the power 6 is going to be A square and the cube. Why I need a square? Because I know the value of square, a square, which is going to be 3 cubed, 5. So it's 27 over 5. Right? There's another problem, it's challenging. I want some of you can do it. I know x plus 1 over x is going to be it's going to be 4. Find the value x squared plus 1 over x squared. Yeah, give me 1 minute, okay? I want to see who can do it. So we have Alex, Andy, Debbie, Emma, Debbie. Can you do that? Harry. Grant, you got 14. How about you? What's your name?
60.
Hmm?
I got 60.
You got 60?
16.
16. What's your name? Alan. Oh, you're Alan. So Alan got 16. Grant, do you agree? Jonathan? Huh? 1/3. Oh my God. So Grant said doesn't disagree. Debbie, are you there? Debbie Shen. All right, so you believe 16. Okay, 14. So how can we get x squared plus 1 over x squared? This is a tricky. You squared. So you get x squared plus 1 over x squared plus twice x times 1 over x. Okay? Then you what? This is going to be 1. Okay, so here's 4 squared. Okay, so here's 16 minus 2. And what do you get? It's 14. Good job. Okay. You know, you cannot guess and try. And if you want to find the x, and usually it is a rational number. Okay. Can we get x? Let's see. How many of you knows the quadratic formula? Jonathan, do you know how quadratic formula? You're supposed to know, right? How do you solve this equation? So Alex, you say you know the quadratic formula? So you multiply both sides by x, right? You get 4x. So x squared minus 4x plus 1 equals 0. Okay, you can find x, but does not mean you have to do that. Okay, yeah. So use the quadratic formula because you're not going to get integers. The quadratic formula says 2 times 1 and 4 plus minus and 4 square, okay, minus 4ac. Okay, so it's going to be 4 plus minus 16 minus 4 is going to be 12, and the 12 is 3 times 4 is 2 square root 3 divided by 2. It's going to be 2 plus square root 3. Okay, so you are going to, but you only can. You get 2 solutions. And both solution works. Okay? Why? And it's magic. If x is going to be square root 3, then 1 of x is what? 2 minus square root 3. How do you see that? How do you see that? So then, the sum is going to be 4. Because square root 3, negative square root 3 cancel out. Okay, but how do I know 1 of x is square root 3? Because 1 of x is going to be 1 over 2 plus square root 3, right? Now, how can I change it? The trick is, right? And then the numerator is 2 square root 3. The denominator is going to be 2 square minus square root 3 square, which is 4 minus 3, which is 1. Right? All right, so maybe I talk about too much about this. So this is a topic I want to stop. Then I'm going to switch to the next topic. Factors. How do we count factors? All right, how many factors does 6 have? Okay, a factor by definition is a number you can divide this number. Okay, so it's 1 times 6 and 2 times 3. So 6 has 4 factors. 1, 2, 3, 6. Okay? My question. How many factors does 24 have? Please do it. Felicia. Felicia says 8. Kelly says 8. Okay, so let's take a look at 24. 24 is going to 8 times 3. 8 is going to be 2 cubed times 3, right? It's a prime factorization. Then a factor must be in the form. A factor of 24 must be in the form 2 to the certain power and 3 to the certain power, okay? But that P cannot be larger than 3. That Q cannot be larger than 1, okay? So in other words, you have how many choices for P? 4. And how many chances for Q? 2. So total will be combined them. They are 4 times 2, which is 8 ordered pairs of P and Q, okay? But each corresponds to a factor, right? To a factor of 24, okay? Okay. Because that's why you have it. So you just need to look at how many choices for P, how many choices for Q. If you know this idea, you can do lots of problems, okay? How many factors does 54 have? And let's please do this. All right, let's factor 54. 54 is going to be what? 6 times 9 first, right? We know that, right? The multiplication table. And 6 is 2 times 3, 9 is 3 squared. Aha, so it's going to be 2 times 3 cubed. So a factor must be 2p and 3q in that form. And here p has a choice, 2 choices. Q has 1, 2, 3, 4 choices, right? 0, 1, 2, 3. So that's why it has, yeah. So it has 2 times 4, 8 factors. Okay? Now you cannot list all of them. Can you list all of them in some nice way? You have to use a matrix. Okay? You can list it of them in the following way: 2 to the 0, 3 to the 0, 2 to the 0, 3 to the 1, 2 to the 0, 3 to the 1, 2 to the 0, 3 cube. Okay? That's 1. Another one is 2 to the 1, 3 to the 0, 2 to the 1, 3 to the 1, 2 to the 1, 3 square, and the 2 to the 1, 3 cube. So you list all of them. Okay? That's called matrix. Okay, have we heard about matrix? Right? There's a movie called Matrix, right? Have you watched it? Okay, so that's called a matrix. If you list, if you have 2 parameters there, you want to list all of them, you have to use a matrix, 2-dimensional matrix. But you have 3 parameters. You have to, it's harder to join. You have to put them in the space. If you go to the Washington, D.C., the Nature Science Museum, and you can see the 3-dimensional matrix there. Okay, you want, describe. Yeah, I saw it. Okay, so this is a 2-dimensional matrix. Okay, this is where you list. Okay, you change the value, fix one value, list all the numbers in one column. When you change the second parameter, Q. Q is from 0, 1, 2, 3. P is, then you let P equals 0, P equals 1, so you get 2 columns. Okay? You don't need to multiply them out. My question is, what is the best way to find the sum of all the factors? Aha. You just add them together, multiply them out. But right now, you have 8, right? Maybe if you have 50 factors, then you have trouble. Okay? So the idea is that row 1, the sum is you have a common factor 2 to the 0, so you take them out. Okay? And then row 2, you got 2 to the 1. Okay? Then add them together, you find out this is a common factor. Add them together, you got 2 to the 0 plus 2 to the 1 multiplied by this common factor. Right? This is the sum. The sum is going to be that. And this one is 1 plus 2 is 3. And here's 1 plus 3 plus 9 plus 27. So 3 plus 27 is 30. 30 plus 9 is plus 10 is 40. So it's going to be 120. No, 2 to the power 0 is not going to be 0, it's 1. Okay? So that leads to the following question. And that leads to the following question. Are you able to add this many together? What is the sum of this? Okay, how to group them together? Right? Suppose you have 100 terms, right? So the idea is you let this to be S. Okay, here's a trick, okay? Then R times S is going to be R plus R squared, R cubed, and keep going. And then you have R to the n plus 1. Right? You multiply each term by R. Then what do you get? Equation 1, equation 2. Equation 2 minus equation 1. So you get RS minus S. The other side, when you do subtraction, all of them will be gone. Okay? So only the left, only the last term it's left, it's minus 1. Okay? So here you have R minus 1 test, and then you solve for S. Okay, so that's the way you can get a formula easily, okay? So that when you apply 1 plus 2 squared plus 2 cubed and plus 2 to the 100, right? Then using that formula, it's easy to get. It's going to be 2 to the 101 minus 1 over 2 minus 1. And 2 minus 1 is 1. So it's going to be like this. Okay? Now, my very last topic is about lines and linear equations. There are a number of the questions about that. How do you describe the line in the space? Just a line like that. Now, you need a so-called slope. Right? The so-called slope. So this is you draw the triangle, right? A triangle. Take arbitrary 2 points. Okay? You are going to learn late. You find out this changing delta y, this changing x. The ratio delta y over delta x is independent of the choice of P and Q on the line. Okay? So this is an important fact. You can prove that using similar triangles later, but we are not going to prove that. So this is an important number. It is called a slope. Okay? It's called the slope. All right, so here's a question. You have a line. A line passing through those 2 points. What is the slope? To -3. Alex. So here, so this point has coordinates 0 and 2. This point has coordinates 3 and 0. So the difference in the y variable is 2 minus 0, right? 2 is first. And then, okay, wait a minute. It's going to be 0 and the 3 0, yeah. So then it'll be 0 minus 3, not 3 minus 0. Yeah. So the answer would be -203. Okay, so that's a slope. Now, with the slope, if I have a point, let's look at the arbitrary point. It has coordinates in x and y, right? So I'm going to use this pair of numbers to find the slope. So the difference, I can use this one first. So I use this two pair first. So y minus 0 and x minus 3, okay? That's the ratio. All right, so this is going to be the slope. So it'll be -203. So if you, for an arbitrary point, you work with these 2 points and use these 2 pairs of points. Okay? Then you can also calculate slope. And then they must be equal, right? It doesn't matter which pair of points you choose. So you get Yeah, you can rewrite this relationship. Right, so this is it is called the linear equation, an equation of the line. Okay. So that tells you what is so-called linear equation for a line. Just for an arbitrary point, they have coordinates x and y. Just tells you the relationship between x and y. They're not arbitrary. Okay. So now you can rewrite this and multiply by 2. Yeah, -2 over 3 times -3 is going to be 2. So this is another why I call an equation, because equation can be in many different forms. In this form, for example, right? That's also called equation. And then I multiply both sides by 3. I get 3y equals -2x plus 6. This is another version of the equation. I can also move 2x to the left. 3y plus 2x equals 6. It is also, yeah, it's equation. And sometimes people write in this form. So there are many versions of the equation. But the key point is, if you write in this form, write this form, what that mean? Okay? This is always a slope. Right? But how about the geometry meaning of this number? This means when x equals 0, y equals 2, right? When x equals 0, y equals 2. So that means this gets the y, this is the y-intercept. This is a line. Right? This is going to be called as a y-intercept. Okay? Yeah, this is a. All right, so whenever you get an equation like this, you can always tell that m is the slope of the line, okay? And the b is called the y-intercept. All right, so finally, given, yeah, let's do one more problem. Given 2x minus 4y equals 1, okay? What we can say from that? Okay, find the slope of the line. This is the equation, right? Find the slope of the line. Okay. Well, right. So first of all, you rewrite this equation. You get 4y equals 2x minus 1, right? And then you divide by 4, 2 over 4x minus 1/4, which is going to be 1/2 of x minus 1/4. Then as long as you get this form, slope m equals 1/2. Okay? And the y-intercept is 1/4. So you have to express in that slope of intersect form, then you can tell the slope from the coefficient. The general form you cannot tell directly.